Well, welcome to the Royal Astronomical Society Facebook live feed, and we're here all this week at the European Week of Astronomy and Space Science here in the fantastic city of Liverpool. And this press briefing is about the square kilometre array. And the nice thing about this is we actually have a square kilometre array model right behind us. It looks a bit like a bouncy castle even, but it's actually a half-size model of one of the telescopes that will be installed across the southern hemisphere. So I'm here with my colleague Marieke Baan, who's from the European Astronomical Society, because this is a joint UK-European meeting and we're delighted to have it here. So, Marieke.
Thank you. We're talking now to Mario Santos. He works at the University of Western Cape, and he will tell us something about the EDGES experiment, in which in Western Australia astronomers found a signal of the first stars in the universe. Tell us all about it.
Yeah, so I'm from South Africa, and I've been involved with SKA for a while now, and one of my interests is using the SKA to probe the neutral hydrogen in the universe, and in particular hydrogen at very high rate when the universe started, so when the first stars and galaxies were formed, and so this is why the EDGES result is so interesting, because it's the first time an experiment shows a result that might be a possible detection of this signature from the first stars and galaxies.
And how do we know that the signal is real?
Well,
because we all remember the South Pole Telescope result a couple of years ago.
So it's a very exciting result and also very puzzling because it's much stronger than what we'll expect. So obviously, that question is an important one. Like, is it real? And I think we don't have the answer right now. I mean, it's very promising, and the team that made this measurement in Australia, they did lots of tests to try to clean any contamination and see prove that the signal is real. But we're not sure yet, so we'll need to wait. Do a few more tests and wait possibly for other experiments to confirm this result. But it is very promising and very, very exciting if it's true.
So Mario, tell us, when SKA comes on stream in the next decade, how much more do you think maybe you'll be able to do with that on this kind of work?
So the SKA is actually being built. The SKA low version in Australia is actually to measure this type of results. So we know with the current specifications for the SKA that it will be able to measure this type of signal, or even signals that are weaker than these. So for sure, the SKA, in the way it works, will be able to confirm if such a result is true. And as I said, it is very puzzling because our models at the moment, they cannot explain these results. So we need new theories actually to explain it. So it's a very exciting result.
So should we bring in Richard Battye now, who's going to tell us about another wonderful piece of news in radio astronomy.
Hi, Richard. You're working at the University of Manchester, and you're co-chair of the cosmology working group of the Square Kilometre Array.
That's right.
Yeah. Can you give us some information about what SKA, what new frontiers SKA will open?
Yeah. So when the SKA is built in around maybe 10 years' time, we'll be able to make the very large maps of the universe. So we'll be able to use the 21 centimetre line that you were just talking about with Mario, but actually at much later times in the history of the universe, what we call lower redshift. And we'll be able to make big maps of the way that the universe is distributed. And what we'll use that to do is to measure the underlying distribution of matter, the dark matter. So we believe that the neutral hydrogen will fall into regions of the universe where the dark matter is the deepest, and we will then be able to use those maps to infer the rate at which the universe is expanding. And the objective then will be to try and model things like dark energy, the dark matter distribution, and possibly modifications to gravity.
It's probably a completely unfair question, but do you have any personal ideas on what dark energy might be?
There's lots of things I've worked on. I'd be very surprised if any of them are correct. I think it's one of the biggest unsolved questions in the whole of science, as much as anything. I mean, what is causing the cosmic acceleration. No one really knows what's causing it. There are many ideas. Every single one of them has a problem. So I think the more information that we have, the more detailed measurements we have, the better we can try and understand actually what's going on, and possibly push us into the direction where the best theories actually are. So to rule things in and out, basically.
And how many years do we need to find out?
To find out what the theory is, well, that may take quite some time, but I think the measurements, hopefully in about 10 years' time, 10 years' time we'll have really improved things by then, and well, we might have solved it by then. Someone might come up with the right idea tomorrow, but I don't think we'll actually know until we've actually done a measurement that is sufficiently accurate to prove that particular theory right.
It's wild speculation, but you don't know. There might just be someone in this conference here today, a postgraduate, a postdoc, or someone more senior, who is just going to have that answer by that time.
Yeah, well, but someone might have had it already, of course, but I think that I'm not particularly attracted to any of the ideas at the moment. So I think the key to it is actually, phenomenology and measurement.
Thank you. Dan, do you want to ask any questions? Or? Okay. Well, I think. Any other questions? Your opportunity. Osna, would you like to come in? So do you want to say where you're from?
Yes. Hi, I'm Osna. I'm currently writing for Popular Astronomy and for SKA as well. So I have a question. So with, for example, things like the Dark Energy Survey, and as we get bigger and bigger surveys, we're starting to see like weird anomalous events. So you might have heard of, for example, the 72 transients that recently just got discovered. Are there any sort of I know this is a bit of a weird question, but are there any sort of signatures of like anomalous events that you think we might be able to see?
Well, the anomalous events by definition are almost things that we don't expect. Okay, so what tends to happen is when you build a new telescope like the square kilometre array, which is, let's say, 100 times bigger and stronger in measuring anything than anything that's gone before it, then what will often happen is that things will, we're planning at the moment all the things that we might measure now, but actually what we might measure in 10 years' time, there might be a whole load of new things that we never thought of that just pop out because we've gone into some region of parameter space that we just didn't expect, we can't really predict. So I can't really predict the unforeseen at some level, but I'm pretty sure that we will find things that are completely unique and new to science in when the SKA comes online.
Yes, it's a good place to end because that's what observational astronomy is all about. You build amazing instruments, and it's the unexpected stuff that always, by definition, surprises us. So,
thank you very much.
Thank you, Richard.
Thank you.
Thank you, and we'll bring you another media briefing, I think, tomorrow and Thursday at the very least on topics to be decided. So watch our Facebook pages, watch our Twitter feed, and we'll keep you updated.